Alrighty, so I think the most important thing is your lab number 4 has just been, oh, sorry, not solution. I beg your pardon, it's a typo. Of course, I'll give you solution later. But your lab 4 instruction, starter code, have been released on the E-class. Okay, so please get started. Lab number 4 arguably will be the most challenging one for this semester. I want to just give you a heads up, but I'm pretty sure you can learn a lot from that particular lab. It's a very good one to really challenge how exactly you can put everything together, also including inheritance that we're just learning. So please do get started early, and then I'll give you guys a solution. And then if you want to go over any parts with it, maybe while you're trying it, let me know. And also, don't forget, we got tracing exercises for you. Okay, I think that one there could be useful, maybe for your written test too, right? Not necessarily the programming test, but tracing will be also important. Okay. And then if you look at the course calendar, I think we got 2 more tests for you. So we still got your written test number 2. That one is coming first. And then we got your final programming test. And that one is going to be based on lab number 4, not lab number 5. Lab number 5 just another exercise for you, just about the inheritance. But that one there will only be covering the exam, not really in the programming test. Okay, so that's more or less where we're going. Any questions about the course? I will gather together with the TA very soon to start grading your programming test number 2, and then we'll try to give you back the result, hopefully within a week or 10 days. I'll try to see if I can happen even sooner, okay? But I'll keep you posted, okay? All right, let's now do a quick recap, and then we'll move on to inheritance, right? So we definitely will dive deeper and deeper into inheritance, okay? We'll see. There'll be some interesting intuition I want to give to you guys today. So that will start you very smoothly for next week as well. So we started you fresh on Tuesday, just about the inheritance, the motivating problem here about student management system. So you can just get yourself familiar with all the terms, which we'll keep repeating. I will introduce another running example today, which has slightly more complicated layers for architecture, like an inheritance, like a smartphone. That one just also another nice example to look at. We'll see. Okay, we'll talk about 2 design principles, cohesion and also single choice principle. This one here, for every class, just make sure you put all the relevant attributes and methods in a single class. This one here, make sure you don't have duplicates. That's as simple as you have to remember. Okay? And then maybe for the actual justification, I wouldn't go in details, but you can check out the recording. I'll post them very soon. So first design attempt without inheritance. The main thing is about using the integer kind. Depending on how many kinds of student you have, you're going to somehow encode the number, 1 for resident students and 2 for non-resident students. And we said that it violates cohesion because you actually put 2 irrelevant attributes in the same class. And it violates also single choice principle very badly when you have to repeat the same kind of discrimination structure for every method. It's necessary, but it's a bad practice for the design. And for the second case study, like a second design attempt, that one there, we just got 2 separate classes instead of 1. And those 2 separate classes simply are separate, but we got lots of duplicates right here, lots of them, right? So that one definitely violates the single choice principle. However, it nicely resolved the cohesion problem because we put these 2 attributes in separate classes, all right? So that's something you also want to just go over and make sure you're okay with it. And then we talk about just how you trace the code. And today we'll actually go in here and show you something that's interesting. So here you can see so far we have this dynamic type and this static type different. But starting from today, about maybe after the first 30 minutes or so, we're going to see in general this and this do not need to be the same. All right, I'll give you guys maybe just some intuition today, but we're going to see the formal rules on Tuesday next week. All right, we'll see that. And then, okay, just more example about single choice principle. And then we talk about this page over here. It's just about storing all kinds of students in a student management system without the inheritance because all the classes have nothing to do with each other. So we're going to store in different arrays over here, right? Also different methods and also separate loops. And it's definitely lots of unnecessary complication over here. Once we introduce inheritance, we'll see exactly how this can be improved. I'll try to draw the reference back once we get there, okay? All right, so that's the final stuff that we spoke about on Tuesday. So this one here just talk about how you can implement inheritance in Java, right? Just very quickly. Let's start with this and going backwards. When you want to think about how you can use inheritance, you can think about, first of all, among all the classes I want to create, do they share anything in common? For example, the way students register, and also students have name, they have courses, they have the counter for how many courses they have, right? So these are all the things they share in common. So anything that's in common, you can factor them into a single parent class at the coding level. So this way, we can declare all the attributes and methods that will be inherited to all the subclasses. In this way, we can minimize duplicates and satisfy the single choice principle. So that's principle number one. Think about what's really in common among all the subclasses. Number two, you want to think about, so if you see that here, right? You can see in the student class, that superclass, you got the green ones are all the things that will be shared by all the subclasses. You never have to declare them once more to duplicates. Number two, over here, in the child class, you can declare something additional. You can think about the child is actually going to inherit not only what's in the parents, but also they can create something on their own, something specific just to that particular child class. For example, in resident students, we declare some new attribute premium rates. In non-resident students, we declare discount rate, right? Just like that. We'll see more examples like that. Final one, which is trickier. For methods that you inherit from your parents, you may not be exactly happy with it. You may want to customize it further. For example, the equals method that every class inherits from the object class. You may choose to override it and maybe give some customized definition, right? That's what we said earlier. And in this student example, we have the get tuition method here in the parent class. That one there simply just add up the fees for all the courses that's registered. And then we can override it in two places. Override it for resident students, where we simply call the version from the parents and apply premium rates. And similarly, in the non-resident students, we try to call the parent version, and then we try to apply discount rate, right? So these are the two overridden versions. And finally, you just have to make sure when you do lab number 4, you will know when to use the extends keyword to build like a subclass, superclass, subclass relationship. And also how to use a super keyword right here, super dot, to call the parent version of the method. And also how you can use the super here, parenthesis, to call the constructor from the superclass. All right. And one of your fellow students from section B yesterday, they asked something here. Okay, I'll put it here very quickly. Okay. So I'll start with that. So let's say, that may be a common confusion. So if you have a class called P, parents, and then so arrow here means extends. So we got child class C extends P. Let's say we got another class over here, grandchild, let's say GC, okay, just for that. Let's say we have a method here in parent class. Let's simply call that M, all right? You have some definition. And then let's say M is inherited verbatim to class C. And right now, let's say in class C, we decide to override it to a different version. So what I will do is, I'm going to say it's really the same M, but I may just say put a star. Simply means somehow it has been overridden. You know, you can call it a super keyword, or maybe you can try to somehow, change the definition a bit. We'll add something additional, right? And then, let's say in the GC over here, grandchild, we also got inherited some version over here. And then we also want to override it. Okay? So basically, we are creating 3 versions of the methods. Okay? And we want to see to what extent can we use the super keyword. Okay? Of course, in this case, you don't use a super keyword because this is already the top of the relation. So you want to think about, let's say here, if I try under this method, if I say super dot M, let's say M doesn't take any arguments, versus here, if I say super dot M. So both lines are valid, but we want to know exactly which version of the method is calling, right? Let's take a look at it. Let's say this one here, you want to say super dot M. This one should be quite easy, right? Because you only got one superclass right above you. So that one there is really calling the version from P. The version from P. It's like when you call get tuition, super.get tuition from resident students is calling the version from students, just one level. Okay. How about here? When I say super.m, which version? Am I calling the version from C or P? Or is it ambiguous?
I think it's version C. Because you go directly to...
Yeah, also you can see there's only one use of super, right? Yeah, that's right. You just call one single super, so that would just go one level up, right?
Can you do super for example?
Yeah, I'll get there. That's exactly what I'm heading to. Just bear with me. So that one would be the version from the child class, right? So far so good, right? Super simply means go one level up. Now the question is, let's say in here, can I try to say I want to get to this method here? Can I get there? All right? Meaning that you may think it would make sense to simply write something like super dot n. Logically, I agree with you. That makes sense. But unfortunately, no, you cannot do it. Okay? I want to mention that explicitly. Whenever you want to use a super keyword, you only have the ability to go up level 1. You cannot say go arbitrarily many levels up. You just cannot, right? So you can only access, presumably, so here goes a little bit of like a rationale behind this design. When you say super.m, that one there should really refer to whatever version this might be in this level. That one there should have already somehow taken into consideration any reuse from this parent here. So that's not something you have any control over, right? So syntactically, you can only say one super. Just go to your immediately above parents. Okay, I want to point it out. Okay?
What if you do testing, for example, if you have an object this and you test it to the parent, can if you do .m?
No, you still cannot. Because which version of the method you're going to call really depends on the dynamic type. When you do typecasting, you're basically creating an alias of different static type, right? You're only playing with a static type when you do typecasting, not dynamic type. Yeah. It's a good question, but you cannot do it. Yeah. Okay, good. Right, that's all I want to say. Guys, any question just about in general, the inheritance? Yeah.
Is there no way for GC to call the method M and P? Only able to go to C?
Yeah, that's correct. So the conclusion is, yes, there's definitely some restriction on the programmer, right? So again, from GC here, you can only refer to the M in C. That's the only way. The only occasion, okay, I can tell you that. Okay, that's interesting. Let me develop a little bit further. Let's say this is scenario number 1. Okay, let's create another scenario. I still have my parent class, and then I still have my child class. I also have my grandchild class. Okay, this one is interesting, okay? Let's say this. I still have M here. Good. And in the child class, let's say I'm happy with it. I don't want to overwrite, so I don't do anything. It's inherited verbatim, implicitly. And then in GC, I decide to actually overwrite M, put a star here. All right? So now, the question is, when I say super dot n, this is valid. But what exactly am I doing here? Yes. Yeah. Yeah. So your fellow students definitely has the right interpretation. I would say there are 2 ways you can interpret this. You can go either way. Both ways will be valid. What your fellow student just said is, because we know this is inherited right here implicitly. So when you actually say super.n, you're really referring to this one that's implicitly inherited from its parents. So this one here is just the same as this one here. That's one way to think about it. Okay? Another way, which is a little bit closer to what actually is happening at the runtime. When I say super.m, that means I will go back to see if this particular class has any overridden version of the m. If it doesn't have it, I will go up to see the closest ancestor. That's what we call. Don't worry, I'll revisit this concept again. The idea would be we want to find the closest ancestor that has this particular method. And in this case, the closest ancestor is in P. All right, so there are two ways for you to actually interpret. Maybe in the beginning, you can think about if this one doesn't override, M is implicitly just overridden here, inherited here, verbatim. Okay, I'll write it down, but the closest ancestor is a very important concept, but that might be a little bit too much for today. I'll make sure I revisit that a little bit later. So think about this one is referring to the version in the closest ancestor. I will define exactly what I meant by ancestor today as well. Version of the closest ancestor. Okay, and the closest ancestor is something we'll define precisely. Okay, you can think about just following the arrow, whatever M we find first, that's explicitly defined, that's the one to take. Okay. Yeah, so these two scenarios are rather common. So sometimes you cannot expect like every child class to override every method from their parents. So you have to decide somehow which version to take. All right, good. All right, let's now move on a little bit, and then let's now, okay, good. Let me talk about how you can visualize objects when you do the tracing, okay? So whenever you want to visualize, let's see this. Let's say we got students, we got resident students, we got non-resident students, okay? Since we are talking about runtime, usually you have to focus on dynamic type. So you can see here, we have students right here, resident students, and also non-resident students, right? So these three represent the dynamic type. 1, 2, and 3. Let's remind ourselves. Whenever you want to figure out the dynamic types, you look at the constructor that's being called. So these are dynamic types. Okay. Similarly, we have this one here. So we have student here. And also we got resident students over here. And also we got non-resident students right here. Right? So these are all the dynamic type. Okay, straightforward. Now the question is, when we visualize the objects of different types, especially we got inheritance in the play, what attributes should we really include? That's the question. Okay? So the way to think about it is you want to somehow maybe draw the hierarchy yourself and see. So we have the student class right here. Okay? Underneath it, we got resident students, and also we got non-resident students. Okay, should put it down first. That's exactly the hierarchy we have. And let's revisit ourselves quickly. Okay, let me just go back to here. So you can see in the student class, we got name, registered courses, and number of courses. These are the three. They will be inherited. Okay, and also for resident students, we newly declare premium rates. For non-resident students, we newly declare discount rate. Right, that's what we have. Let's see how we can reflect this back. So back here, for students, we got name, registered courses, number of courses. So these are the three. They will be inherited verbatim. It will be as if we also declare them right here, as if. Okay? Not explicitly, but implicitly. So that's why when you try to visualize the student objects, of course, you got to include all these three attributes, right? The name, number of courses, and registered courses. And part of the attributes for resident student, you will also see these as well. And also part of the non-resident students, you also see that, right? It's there, it's incorporated, right? And what you will have also in addition, like a unique for each child instance, will be the actual additional attribute you declare. For example, for resident students, we actually got premium rates. So premium rates, and for that one there, we got discount rate, right? PR and DR. So that is why you can see premium rates right here, and also discount rate right here, okay? In this particular example, it's not too difficult to figure out because we only got like 2 layers, right? You only got layer 1 and layer 2, right? Only 2 layers to accumulate the attributes. But when you actually got more layers involved, you got to be very systematic, which is something we'll show you as well today. We'll do some exercises together. Okay. Visualization. Questions? Okay. And then let's now, so this is just to remind you. So that's the hierarchy, right? For student, student, and non-resident students, right? So these are the attributes and methods that we just went through. Just keep this diagram handy. I'll also remind yourself, all right? And this fragment of code is just to remind you also. So let me just show you very quickly. We don't need to go in detail for this one here. Let's say we got resident students, and that's for Jin. So Jin, dynamically, resident students. That's why we got premium rates, right? And also we got Jeremy will be non-resident students. So Jeremy and also non-resident students, and then the discount rate, right? And then, so let's say they're classmates, so they are enrolled into the same 2 courses. And now the question is, when we call these 2 lines right here, Jim.get tuition, and also Jeremy.get tuition, right? So these 2 lines, I'll make it a little bit bigger, okay, right here. So now, how are these 2 going to be different, right? To see which version is going to be called, use our knowledge from the equals method lecture. You can see right here, Jin, here, the dynamic type is resident students, right here. And for Jeremy, the context objects, the dynamic type is non-resident students, right? Right here, okay? This one tells me this get tuition is going to be the version from resident students. It's going to be the version from resident student using premium rates, meaning that we're going to use this 1.25 to calculate, right? Apply to the base amount. And similarly, when you actually do get tuition right here, it's going to call, according to the dynamic type, the version from non-resident student, which we know is going to involve the discount rate right here, okay? The exact number that's going to be calculated is not important, but it's important to see which version it is going to call. Okay. All right, question? All good? Okay. So I think today we'll talk a little bit more about dynamic binding, which is going something very similar. I'll try to see if I can do some Eclipse demo as well, just to show to you, like a step into. Yeah.
If I have a child and I cast it to another child and call the method, I know the dynamic type will not change. But will it give a runtime error because of something else, or it will run normally calling the actual run?
Yeah, so you're basically talking about when you do typecasting, right? What's going to happen? Well, bear with me. You got to wait for maybe 2 classes, because 2 lectures, because we're going to talk about when you do typecasting, there are 2 issues you got to face. Number one is the typecast compilable? Does it even compile, right? If it doesn't compile, you cannot even run it. And number 2, even if the typecast compiles, you might also run into the class cast exception, right? So let me delay that answer to you, right? Because it might confuse everybody else, right? We'll talk about it, don't worry, thoroughly. Yeah, next week. Most likely Thursday, yeah. All right. And so guys, I would suggest we do something very, okay, actually we do 1 or 2 things. Okay, how about this one here? This one is a little bit slight distraction from us, because I think this one is important to talk about, which is about visibility, okay? It's about using modifiers, which is quite common in, I would say, all the OOP languages, like a C#, maybe, I'm not too sure about C++ though. Maybe they got something similar, like a public, private, protected. Yeah, I would think so, right? Yeah, maybe similar. Okay, I'm pretty sure C# is similar to this, right? Okay. Yeah, okay. Let's now talk about modifier. This one wouldn't take long, but we're just going to know how to deal with it. And I would say once we talk about the 4 different options for you for modifiers, you can apply them, experiment with them, maybe in your lab number 4. That's really the best way to practice. Okay. Let's now do some notes quickly, just summarize. So we call modifiers in Java. Okay. And whenever we define modifiers, it's really to do with visibility. Okay. And I'll explain what visibility really means intuitively. So let me just say that verbally. So when I declare an attribute, for example, if I declare the attribute to be private versus public, how is it going to impact how visible the attribute is. So is the attribute only going to be visible or usable within this particular class, or within the same package, or within the same projects, or outside, right? So that's kind of about visibility issue. That's something we gotta go through. But it's very intuitive, right? So let's enumerate all the possibility for modifier. Let's start with something called private. It's a keyword. I'll underline it, so that's a keyword in Java. I'm pretty sure I have used it already. And number 2 is no modifier. Okay, I'll show you an example. If you simply don't put anything, just say int x without anything before that. But if you say private int x, in that way you got private, right? It's a modifier. It's no modifier. All right, number 3 is something called protected. And this one, I can make let's make a very quick notes. So whenever you're using protected, that means your intention is to really make the variable visible to all the subclasses of this current class. And the subclasses may or may not be in the same package, right? That's a very quick summary, but you will see exactly what I meant. So this is to do with our inheritance. And of course, you can definitely give a try on lab number 4. Yeah, and then we have number 4, public. Of course, that's something you have seen before. All right. So all of these are applicable to attributes and methods. Okay, for attributes and methods, you can definitely use any of these modifiers. All right. But we'll see exactly what the consequence is, and then you can choose. For this course, there's really no right or wrong, like which one you have to choose. Also, for the programming test, we don't really try to see if you try to use the most suitable, like a modifier. For programming test, as long as you can pass the test cases, you're good. But I think the reason I want to give you this is there might be some design kind of involved, so that's something you want to maybe also experiment. So beyond this course, you can still apply that technique. What about classes, right? So for Java classes, you can only got these 2 choices, either no modifier or public. Only these 2, okay? Only these 2 classes. Okay, it's a very quick summary, but the way to really get used to this, there are two things I would suggest. Number 1, would be just to experiment this in Eclipse. I set up something very complete already for you. All you got to do is to go over that at your own pace. I'll show you where you can find it. So if you go to the lecture site, you will see that in the inheritance section there, under the codes. So there is a project called visibility, right? So that's the one to import into Eclipse. Okay, I already imported. I'll show you just one example how you can make use of it. So if you import a project, you will see there are many projects inside the zip, right? Don't be too scared. That's really the way it should be, okay? And there are many compilation errors over there. Just to show to you, when you actually use the visibility in the wrong way, it's going to give you compilation error, okay? Just one example. If I go under, for example, class level attribute method, right? Just one example. Under the source, we got 3 packages. Let's say, for example, if I go to furniture, go to desk, right? If you go in there, in this particular class, you can see here, I got one compilation error. I call c.n. And the class, the method n comes from the chair. So why is it a compilation error? If you go to the chair class, you will see that method n is actually private. That would mean the method n is only visible within this particular chair class, right? It's only within there, so you cannot go outside the chair class to access it, right? So that's something you can actually play with. You can modify it, or if you want to go over the comments I put over there, and then you will see. Okay, just supplement what I'm going to say in the next few minutes. Okay, I'll leave it to you. Okay, the resource is already there. Just take your own pace to go over that. Now let me give you the intuitive but thorough account for how you can understand these modifiers. Let's start with a simple case. Let's say we got classes. Okay. Again, let's say we got a project there. Let's just call collection of stuff. Right? We got three packages. We got animal, we got furniture, we got shape, right? We got cat, dog, chair, desk, circle, and square, right? Just simple classes over here. And the first one, if I declare my chair class just saying class without public, that would mean this chair here is only visible within the current package. Okay. So this no modifier, meaning that it's visible within the, we say the residing or resident college, sorry, package, residing package. Basically the same package as the class, all right? So you can definitely put in the desk method here, desk class over here, you can declare chair C. So this is accepted, right? You can do that for sure. On the other hand, if I try, let's say in the circle class, I try to declare a variable called of type chair, let's say C2. I cannot do it, right? It's not visible. It's only visible within that particular package, all right? Not good. Hey. Sorry, say it again. Yeah. So this is visible to all other classes, but in the same furniture package. Yeah, it's package level visibility. Yeah, exactly. So for example, if you try maybe declare chair inside cat, also you cannot do it. It's a different package, right? Yeah, just about which package you are in. And then we have public. That one, straightforward. Oh, sorry, let me finish this. I'll take a question. So for the public here, that means it's visible to everywhere else, just everywhere, right? That's why I put green, right? Everywhere. You can just declare a chair anywhere. Question?
So what happens when we declare multiple classes in one file? Like if you have one class file and then you decide to declare multiple classes?
First of all, I don't think you can do, let's say, multiple, like a class in a single file. I think that there will be some error from Eclipse.
Because you have to, the package, the name of the class has to be the same name of the file.
Yeah.
You can have inner classes, but to be in.
Yeah, exactly, yeah. So what your fellow student said is also right. So here's the thing. Number one, you cannot have, let's say, I declare class C1, and then followed by class C2, followed by class C3. You cannot do that. Because when you name the file, it's going to be c1.java. That means there should be only one single class that's public or package level in that particular file. If you really want to have multiple classes, what your fellow student said is all right. It's something called inner class. But that's something we don't really cover here. Arguably, that one could be kind of confusing, but I think that could be convenient to use, but we don't really cover that in this course. Okay, inner class. Yeah. Okay. Good. All right, let's now take a quick look on how we can do for attributes. You got four options here, either private, no modifier, protected, and also public. Right? Let's go in this order. And let's make some assumption here. Let's say we got a chair class. One moment. We got a chair class, and then that one there has two subclasses. We got bubble chair in the same package. We got rocking chair in a different package. All right, just for illustration. So you can see I put extends arrow here just to show to you. Right? Sometimes you may have maybe different subclasses in different packages. It's possible. That's exactly why protected was designed. Question?
When I type now, you can do actually different ones, but only one can be public. The name with the name of the file.
But others, okay, I'll take a look.
Others will have to be.
Yeah, like a not public, right?
Not
Okay, we'll get there. Yeah, thank you. Yeah. All right, let's now take a look at this, okay? First of all, let's start with the private right here, all right? So private here, very straightforward. It's basically only visible to that particular class where it is declared. So now for W, because we are declaring that inside the chair class, right? You can see the chair, okay? So here, we have only visible right here. Only this class you can refer to W, only this class. So I'll put W right here, okay? Just that, nothing else. And then we have the package level, like a no modifier, X. That means every class in the same package as chair. We can see that, we can view it, right? So that one there, let's now put purple. Okay. Of course, in the chair class itself, it will be visible. Okay. The chair class itself is good. And also in the same package, we got bubble chair and also we got desk. But it cannot go outside this particular package. You cannot. Okay. So that one will be for X. Okay. And what about protected? One way for you to remember, there will be some memorization, of course, unavoidably. I would say, think about protected here is more like this. It has two parts. One is package level. Package level, as if there was no modifier. But one more. Subclasses that may not in the same package. Not in the same package. Okay, let's see exactly how we can visualize this. So for case number 1, okay, so for Y, we are gonna have right here. First of all, it should be the chair, right? The same class where it is declared. Package level, so every other class in the same package. Right here. Bubble chair. Also, desk. Right here. So far, the blue and the purple are the same. But blue has one more, right? Which is case number 2. Any other subclass of chair that might be in a different package, they can also see this Y. So that one there is going to be rocking chair. However, you cannot refer to, let's say, X in the circle, because circle is in a different package, but circle is not a subclass of chair, so it cannot be. Only subclasses that's in different package. All right. Finally, so that one is about right here. That one is Y. Okay, finally. So we have right here Z. Public, well, everywhere, basically, right? So it can be the class itself, basically every class. Okay, let me just be complete and make sure I finish that. So every class in the same package, also every other class in different packages, right? Just like that, and like that. Okay. And you also see a table, actually on your slides. That one there is now saying the same thing. Private means it's only visible in the same class that you declare the attributes. No modifier means package. So the class you declare it, and also the package, and in some way, if your subclasses are in the same package, they're in the same package, right? So it's really the same thing, okay? But if you say protected, it's gonna be the class itself, also all the classes in the same package, and also subclasses in different package as well, right? That's exactly what's in addition to the package level. For public, just everything right here. All right, so I think the table, if you prefer this way to kind of help you understand or use the visual one I just did, either way. You also got an Eclipse project to really import and play with. Right. Yeah. Question? Yeah.
Right now, when you do internal classes without public, it's only available for the package. It doesn't for any classes in the packages.
You mean the inner class, right?
No, not an inner class. If you do one public and the other one without anything, without a modifier, the other classes, you can access within the same package from anywhere inside the
Right.
But you cannot access from other packages.
Yeah.
But when you do public, you can actually test. You can actually.
So it does sound like if you got multiple classes in the same file, the only one that's public, of course, is available everywhere. And also other non-public classes, they're just within the package. Yeah, that's a consistent rule that we just spoke about, right? Good. Yeah. Thanks for letting us know.
Question?
Yeah.
Since the chair is public, when you say, for example, the X can't be accessed in another package, do you mean that, like, if you make an instance of chair in another package, you can directly access?
Okay. So we have two distinctions here. When you say the chair itself is visible, that simply means, let's say in the rocking chair, if I declare chair as a type, and then C, I can do it because chair is simply visible. If chair itself is only package level, I cannot even refer to chair, right? And then assuming that the chair is already visible in this particular rocking chair, and then let's say got an instance of chair called C, let's say. Can I say C.W? I cannot, because W is private. You cannot do it. Can I say C.X? In this case, I also cannot, because X is supposed to be visible only within that package, but I'm now in the rocking chair, so I cannot do it. Can I say C.Y? Yes, I can, right? Right? And etc. Right?
So obviously this is if you don't have like an accessor or a getter.
Yeah, well, there's another point that's good. So you should really try to avoid to access attributes directly. You should always get some accessible mutator, right, to really go for that. But, programmatically, people can just do whatever they like, just to make it work. But I think that's why we also got 3311 to kind of learn about what would be a good design that can last your project for longer, right? Yeah. Yeah, exactly why you don't really want to get directly access to attributes. That's more like a design issue, so we don't have time to talk about. But if you're interested, we can talk about doing office hour. Yeah.
Also, I've seen some code bases that encrypts the values to avoid cheating. So it encrypts the values, and you have accessors, and the accessors to actually interact with the value. Because if I access the value by itself, you cannot manipulate it. It's just an encrypted value. So the accessor will decrypt it for you and give it, and the mutator will encrypt your value and put it. So you need something to.
Yeah, you need something to maybe like an extra layer of protection. You want to avoid to give the, let's say if you're returning a reference type. But of course, we don't really do that exactly, but in practice, you may want to avoid giving that exact reference back to the people, right? You may want to give a copy of it instead, but it's a different concern. Yeah. All right, guys, how about we take a short break? I think it's now a good time. So after the break, we're going to talk about expectation, and then I want to talk about polymorphism and dynamic binding intuitively. All right, so let's now take a short break. All right, so I would like to start us with one very important exercise about static type and expectation. So if you recall, back in the equalities lecture, we kind of mentioned about static type. Static type basically is what you declare a variable type should be, right? So let's revisit that, and then we just want to make it more general, especially in the context of inheritance. So here, expectation, right? First of all, let's start with static type. So the expectation is really determined by the static type. Determined by the static types of the variable. For example, so here you can see we got 1, 2, and 3. 3 variables. What are their static type? You got to look at the left-hand side. So you got student here. You got student here. You got resident student here. And also you got non-resident students right here. Right? So these are the 3. Okay? So the exercise is really about when I say S dot in Eclipse, it's going to appear a list of attributes or methods you may get access to, right? Assuming that attributes are public, right? Let's say, okay? So here, what should we do? So let's say, let's just remind you for S over here, the static type is students. For RS, the static type is resident students. NRS, the static type is non-resident students. So what we're asking right now is I listed all the attributes and methods that are from this particular inheritance hierarchy. Right? Let me show to you. The name, courses, number of courses. Name, register courses, number of courses. And also I got a register method. I also got get tuition right here, right? And also I got the premium rates. I got set premium rates right here. I got discount rate. I also got set discount rate right here, right? I got all the methods, all the attributes right here for this entire hierarchy among the 3 classes. So now here's a simple question. When I say, for example, S dot name, should it compile? Okay. Versus if I say RS dot PR, premium rate, should it compile? and etc. Okay, we're going to fill out this table here. So once we see the solution, but you can think about it, but once we see the correct answer, so there is certain pattern you can see about inheritance.
I have a question. Can I change the visibility of a attribute in a subclass? For example, if I have int x in the parent class, can I say private int x in the subclass or something
Right.
like this? I change the visibility.
Right, so you cannot really change the visibility actually, because once the parent, if the parent class already declare, let's say the attribute to be private, you just cannot use it. It's just not visible to you. So that's why, in general, if you really want to make sure you can access to your parents' attributes, either no modifier, even in the same package, or public, which is not recommended, or protected, right? Yeah. Mm-hmm. In some way, like a visibility is more like a declaration. Once you declare that, you cannot change it, right? Yeah. Right, so why don't we try the fill, right? How about this? When I say s dot, what will be the range of attributes or method that's going to make it compile? Anyone? I'll let you try first.
The native things for S, which is student, is name, courses, and NO.
Number of courses, and then?
NOC, all in the same package. If we're in the same package.
Let's say they are in the same package, yes.
In the same package, then name, courses, and NOC.
That's it?
I don't think it could.
How about register?
This is the function. The register, the constructor itself, and the
Get tuition here, right?
petition.
Uh-huh.
You can see that function.
Okay, good. Okay, so far you're saying this part here should be okay, all right? How about PR, premium rate?
It's not even in the class.
It's not even in the class, okay? Guys, that's the main thing, right? So this row here, let me write down the correct answer, okay, right here. So here, all the way to here, compile, all right? All these are child-specific. PR, set PR, belong to this child class. DR, set DR, belongs to this class. So they are not available there, okay? So we say that this part here, name, register courses, number of courses, register, and get tuition. So this is so-called expectation for the student class, okay? I'll put it down in a moment. Okay. All right, how about second row? Second row, important, given that the resident students is a subclass. Do we have at least as many expectations? We do, right? That's a key thing to observe, right? So now, what should I mark as green?
The same, I said from name to get T is the same, and then you add extra, which is PR and set PR.
Mm-hmm. Okay, but because these two are declared over there, on the other hand, DR and set DR, they belong to more like a sibling, we call sibling class, right? They just have nothing to do with a resident student, all right? So for this one here, also we can go all the way up to, only up to here, and then also the DR and set DR, right? Declare in the non-resident students and here. So that's basically the overall answer, right? But let's now try to read a little bit more into it, and then we'll do polymorphism, okay? The way to read this is this part here, the range of methods that's defined in the student class. So this part here we said is the expectation of the students. You can think about expectation for the students is also inherited to its two subclasses, right? Number one, okay? Number two, you can think about this part here is the new expectation that only belong to the resident students. And these two are the new expectation for another subclass, okay? So this one here and this one here. So these are the additional expectation for child classes. Okay, of course, the parents cannot live up to the children's own expectation, right? So they cannot.
parent attributes in the other packages.
Mhm.
But will you be able to access them here? Because here in the same package, so for example, this function or the declaration here is in the same package as student. But actually the resident student and non-resident student are declared in a different package.
Okay, so definitely that will be subject to visibility rule. I agree with you. We can definitely refer to what we just said. But for now, for simplicity, we assume all the three classes or any hierarchy that in the same package.
Oh, okay.
Yeah, we assume that. Okay, I can put it down actually, just in case. So we assume from now on, all classes in the same package. Of course, if they are in different packages, in that case, it depends how we declare the variables, right? That will be another issue. Yeah. All right, this is very important, and we're going to apply this insight right away. All right. Let's now talk about two things. Okay, I want to talk about it intuitively. Number one, polymorphism. All right. So now, again, you got to remind yourself about this hierarchy here, about the expectation, right, for different static type. Let's say this. We declare S and RS. And then we, RS over here dynamically is a resident student, Rachel. And then we set her premium rate to be 1.25, right? That's just write down what we have. So S over here is simply, S is pointing to a new students. Students. And the name of the students, Stella. There are other attributes as well, but we talk about visualizing it, right? For now, I just focus on the name, just Stella. We also have another one here, RS, all right? So RS is just another object over here, okay, right here. So that one is resident students. And of course, we got Rachel, the name, and also we can set premium rates, right? We talk about resident student objects should also have premium rates. So right here, we have the name and the premium rates, 1.25, and that one there is Rachel. Okay, that's what we have achieved so far right here, right? So now, question for you guys, intuitively. We got S assigned to RS, RS assigned to S. Now, which one should compile and which one should not? I can tell you exactly one of them is going to compile. The other one is not. At this point, you don't really need to be correct. I want to give you some intuition because for those of you who might be seeing this for the very first time, right, they can look confusing. It looks like, oh, when you say S, if you swap the order, is it really going to make a difference, right? Anybody would like to take a guess? Why don't you take a guess first? Yeah, go ahead.
4 is correct and 5 is incorrect.
You think 4 is correct and 5 is not correct. What will be your justification?
Because the student class is the parent class from the child class, resident student and non-resident. So if we're assigning like S to RS, it's basically saying like student S equals new non-resident student. So it would compile.
So why would it be wrong when I say S is like a residence? You'll be wrong.
The RS equals S.
Why would that be wrong? So you're basically, well, I just want to see what the intuition, right? So you're saying that this should not compile. That's what you're saying, right? So according to your logic, this is like a RS is assigned to basically like a new students, right? Why would that be wrong? What's your intuition about that being wrong?
I think because like we can assign like a child class to a parent class.
I agree that's a rule. Yes, I agree. Your answer is correct. But why we cannot assign parent objects to a child variable? Why is that? That's the main reason I want to explain, right? Okay? Yeah, go ahead.
When the test one at 4, which is S to S, you're reducing this child into a parent. So since the child has everything the parent has plus extras, you can still access them as when you're doing child. But the inverse is not true. When you're trying to have a parent be set to a child, now you're trying to, some variables you're trying to access like premium rate doesn't exist in the parent. So trying to access things that are non-existent.
Yep. Yep, pretty accurate. Yeah. So I think I'll just kind of try to really talk about what your fellow student was trying to justify, which is exactly correct. But let's now do something you kind of get exposed to before. Proof by contradiction. All right? You kind of heard about that before. So basically, this one here, okay, let's make some conclusion here. Okay, first of all, this one here is going to compile. However, this one here is not going to compile. But I want to see exactly why. Just in case you guys forget, this will be one way to kind of recall. Okay? Proof by contradiction is, if I want to show that this will not compile, why don't I assume it's going to compile and then execute it accordingly and see what's going to happen. If assuming that it's going to compile, it's going to lead to some disastrous consequence, then that means it shouldn't really compile. Right? So that's the logic. Right? So now why don't we say this? Number one, assume RS assign S compiles. Assume. If somehow this assumption here is going to lead to something not pleasant, then this assumption should be wrong. So it shouldn't compile, right? Let's say assuming that it compiles, that means we should really execute the variable assignments. So number two, you have to execute that at the runtime. Execute the variable assignments. So what I would do is RS, rather than pointing to here, it is going to point to wherever S is pointing to. Right here. Agree? Okay. And then let's now talk about RS specifically. RS is basically like the RS right here with the static type resident students. As part of its expectation, we can do premium rates. Agree? From before. All right? So number three, expectation of RS static type, which is resident students, includes premium rates. So that means we should be able to do something like RS dot premium rates. Now, when we execute this, RS dynamically is pointing to a student object, but the student object have premium rates. No, it doesn't, right? As we said, student objects only have all these, not including the premium rates. So at the runtime, it's going to crash. There's no such field, right? So this one here is going to crash because student has no premium rates. So following this, we know that our initial assumption should be incorrect, right? That's how we show it, okay? So number four, the assumption is wrong. So RS is assigned to S should not compile. So on Tuesday, next week, I'm just going to dive a little bit deeper into some substitution. But for today, I just want to give you some intuition. So which is, whenever you're seeing variable assignment here, one side is the parents, the other side is the child. If you're not exactly sure which side you should really go, you can try to reason yourself, just in case you forget. If you simply memorize the rule, you might forget about it at some point. But I think to somehow see how you can reason about it, that might be a better way to stay. All right? But we'll talk about the rule on Tuesday. Let's not worry about cast just yet. We'll get there. Yeah, you can just confuse about your fellow student at this point. So we'll worry about typecast maybe next Thursday. Yes. Yeah. Okay. All right, next one. So for now, you can remember that whenever we want to do variable assignments, this side here should be the parents, and this side here should be the child, right? Also, if you refer to the slides, I also try to write this out as well. For both cases, you can also take a look. But I think that this one here, to know why it wouldn't compile, is very important, okay? Let's now try to build on that. Now, this will be the first time you will see something like, okay, just give me one moment. Okay. Let's now try to trace this code right here. Okay, so you can see S over here, RS, and S and RS, right? So that's something we're going to trace exactly, okay? Let's now try this. So I have a new course right here, 2030. And then I declare S statically as students, all right? So if you can think about the static type for students is, for static type for S is students. I can even put it down here, right beside S, okay, right here. I got two objects here. I got RS, I got NRS. RS is a resident students object right here, okay, and Rachel. And then I will later on set the premium rate to be 1.25, which is right here. I got another NRS. Dynamically, it's non-resident students. You can see NRS. Dynamically, it's non-resident students. And then I'm going to later on set its discount rate to be 0.75 right here. All right? Straightforward tracing. Okay? Let's now focus on these two assignments very quickly. This is one here, and this is another one. From what we just justified about polymorphism, these two should be compiling. Because if you look at the static type, if you look at just S over here on the left-hand side, the static type is simply students, which is the parents. On the other hand, if you look at the right-hand side, RS and also NRS, if you look at these two, their static type, this one will be resident students and non-resident student. But the other subclasses, right, it's okay to put it on the right. Right? We justify exactly that. But now, we want to go one step further. When you actually execute these two variable assignment, exactly how we can trace it and to monitor the changes. That's something I want to talk about. All right, let's now talk about it. What I want to do is, let's now divide them into different steps. Okay, let me give you 4 timings to consider. Let's say right before the variable assignments, I would say number 1. Right after that, I would say number 2. All right? And then, after the final one, I'll say number 3. So there are 3 timings, not 4, just 3. Because you can think about whatever I finish right here is going to be followed by this variable assignment. So there are 3 timings, basically, right? So 1, 2, and 3. Okay, let's now draw a table to see what's going on. At the same time, we will also try to trace the code.
Don't I include the system without I know it doesn't change anything, but shouldn't normally I include the statement in between as a timing? Because from 2 to the beginning, there is a statement in between.
Yeah.
I know it will not affect
Yeah.
it's an accessory, but in general.
I do see what you mean. Oh, I see what you mean. I see what you mean. Yeah, you're actually quite right. Yeah, I'll take your advice. I agree with you. Since we only also got one accessor call, right? We don't know. Yeah. Okay, I agree with you. I'll change. Okay, let's say right before is number 3. And right here is number 4. Okay, let's now do that. Okay, I'm going to draw the table right here. And then we're going to have the different steps, right? The step. 1, 2, 3, and 4. And for each step, I want you to look at the static type and also dynamic type. And we're going to focus on just the variable s right here. Okay? We're going to see exactly how variable s is going to change its static type and dynamic type throughout. All right? One column we can already say for sure, static type. Remember we said static type once declared never changes, right? So that one there you don't even need to consider anything, right? Yeah, exactly. It's going to maintain to be a student right here. That's absolutely correct. So you can think about this part here. It's just going to be just the same, just students. Okay, students. Okay, throughout. Static type always the same. Now, we want to see what's going to happen right now, right? How about timing step number 1 right here? What should be the dynamic type? Even before we assign this. S is pointing to basically no, nothing. Just no dynamic type. That's valid, okay? Just don't forget this kind of edge case. So this one here is actually going to be just null. You can think about at the moment S is just pointing to null. I can make it more explicit for you, right? Because we just declared that right here, okay? And then let's now try to do this variable assignments. This one here. S is assigned to RS. S, rather than pointing to here, is going to point to wherever RS is pointing to. All right? This is S is assigned to RS. Now, for this timing, step number 2, timing. What should be the dynamic type? Yeah, because this is, it's really pointing to dynamically this object here. That one is resident students, right? So you can see we've effectively changed to resident students. Guys, it's very important at this point, S is pointing to an object dynamically resident students. This tells us if we try to call a method on this object, the resident student version is going to be called. Accordingly, if I try this, s.get tuition, I know that S over here has the dynamic type right now, resident students. So the get tuition here is going to apply the resident students using premium rates. Agree? Right? So that one there basically is going to be, like a 100 and then 1.25, right? It's going to be 125. Yeah, just do the math, right? And of course, this one here, we don't really change the dynamic type, the get tuition. That one just accessor, right? So that's why when we get to number 3 here, the dynamic type at this point is still resident students. I'll just put it there at this point. Now, the second variable assignments, which is the one here. What if I do S is assigned NRS? Important. S, rather than pointing to here, is now going to point to wherever NRS is pointing to. So that's S is assigned to NRS. So now we change its dynamic type to non-resident students. So this would mean when we try to call the subsequent line right here, S.get tuition, right now the same context object right now dynamically is pointing to a non-resident students objects. So that means we're going to apply the discount rate right here. So discount rate applied to 100, so it's going to be 75. Question? Is it clear?
I have a question in general. What if you said we cannot have a class be set to a parent,
Parent assigned to child.
You can assign parent to child, but you cannot assign
Child to parent, yeah.
child to parent. But what if you
Cast?
what if you first had a parent, you had a child, you did it for you made it a parent for some reason, maybe you're storing it in an array or something for multiple childs, and then you want to get back the child to get something that's specific to this child. So for example, like you had here a child.
Let's delay that because I'm not exactly sure. Maybe let's carry on with that, maybe after class. I'll be happy to do that, okay? Yeah. So guys, let me summarize very quickly and then I'll do one more thing, okay? This one here is really about how the dynamic type can change, right? So when you study for this one here, you want to pay attention to, first of all, S over here has a static type students. If I put S on the left-hand side of the equals assignments, the right-hand side can be anything that's a subclass, resident students or non-resident students. So when I execute these two variable assignments, I basically say initially S just pointing to null. I can let it say reassign that to resident student objects, and later on reassign that to non-resident students. In that way, I'm basically changing the dynamic type. So that's why when you look at these two lines, they look exactly the same. Same context objects, the same method. However, when you trace the code, you should really be able to tell that they are going to call different version of the get tuition. At this point, S has the dynamic type resident students. That's why you're going to call the get tuition from resident students using premium rates. At this point, S has the dynamic type NRS. In that way, you're going to call the get tuition from non-resident students using discount rate. Okay, it's a very important insight. So when you actually try to work out, for lab number 4, you might run into similar situation where you want to see for the same method, which version is going to be called. It depends on the dynamic type of the context objects. All right, good. I got about 5 minutes. I want to do something light just to prepare us for Tuesday. Wouldn't be long, okay? Let me just do, first of all, just a quick reminder again. There's something you have seen already, but let's now emphasize again. Whenever you want to decide compilation, just always remember you have to look at the static type. Whenever you actually want to look at what's the behavior at a runtime, you have to look at dynamic type. Okay, just always remember. And when we say runtime, example could be the version of the method you want to call. For example, get tuition, which class should we go? Equals method, which version should we get? Method call. And also, is there any exception that can occur? Specifically, something called class cast exception. So hopefully we'll get to the class cast exception around Thursday next week. Okay, we just need to pave a little bit more foundation. Okay, let me talk about a few more things, and then we're done for today. So let me just talk about some hierarchy here. So you can imagine if you got, let's say, students, underneath it we got domestic or foreign. Under domestic, we might have either resident or non-resident. Under foreign, we also have resident or non-resident, right? You got a hierarchy over here, right? So what you really want to think about, right? I'll leave that more like an exam kind of a practice, right? If you are given this particular hierarchy for the kinds, if you follow through design number 1, how would you do it, right? So for example, if you go for design number 1, how would you use the kind variable? Okay. Versus if you actually got design number 2, how many classes do you need, right? How many classes? And if you go for design number 3, which is about using inheritance, right? In that way, how would you build the hierarchy using the extends keyword? So these are the 3 things you can think about. So you got different designs using extends keyword. Okay, think about it. All right, so now let me talk about one more thing. Okay, we're good. Just this one here. Okay. This will be another running example we're going to do. The smartphone here, the models are pretty old. I haven't really updated them. But anyway, so you get an idea. Okay. So let's see what's going on here. Okay. So what we have is, we have a class over here called smartphone. And the most basic feature for smartphone would be we got dial and also surf web. That means these two methods should be inherited to all the subclasses underneath it, right? Dial and surf web, right? I'm talking about this for the last thing for today. So when we come back on Tuesday, I will assume you're kind of familiar with what's going on over there, all right? And then we got two branches. We got one branch for iOS, right here. We got another branch for Android. Oh, sorry. We got another branch right here for Android. Again, the models are pretty outdated, right? Just bear with me, right? So under iOS, we got iPhone SE, iPhone 13 Pro. Also Android, we got Huawei or Samsung, and then we got different models right here, right? Just different names. Okay. Let's now look a little bit more into the methods quickly, right? So now if you look at smartphone, it has a subclass called iOS. Right now you can see that the surf web over here is an overridden version about the surf web right here. You can think about maybe we say in iOS, whenever you want to surf web, you'll be using Safari, let's say. Versus in the Android, you might just use Firefox, right? Just an overridden behavior, overridden. Okay. On the other hand, let's say on the iOS, we also got some additional feature method called FaceTime. So this is like a new. And Skype is also only exists in Android. Also new. All right. And then you can see that here for iPhone 13 Pro, let's say we also introduce a new method here called Quick Take, only for iPhone 13 Pro, only that one, okay, additional one. You can see that's kind of applying our principle. In a new class, like a subclass, you can either overwrite or you can add new things, right? Give me 1 minute and then we're done, please. Okay, that one there, we got basically Quick Take, right? Some new stuff here. And then for Samsung, we just got something additional called Side Sync. So this new stuff will be inherited to also the classes underneath it. One more thing, and then we got Zoomage just for this particular model right here. All right, so before next Tuesday, you can actually go over this hierarchy here to get yourself familiar about the hierarchy here. And then we're going to use this as another running example. So next Tuesday, Thursday, we'll talk about substitution, typecast, etc. Thank you so much. See you next week.